Question 9. A machine is used to pack boxes of peaches. There should be exactly 8 peaches in each box. To check the machine, 10 boxes of peaches are selected on the hour for 5 consecutive hours. Each hour, the number of boxes containing 8 peaches is recorded. Okay, so looking at this table then, at 1 a.m. they took out 10 boxes, and out of those 10 boxes, 8 of the boxes had exactly 8 peaches in them. Here at 5 a.m, out of the 10 boxes they checked, 9 of the boxes had exactly 8 peaches in them. The company puts a label for each box contains at least 8 peaches. Explain why this label may not be suitable to use on the boxes of the peaches. Okay, because we haven't got all the information. So we know how many times we get at least 8 peaches in the boxes, but if we consider this one, we know that 8 times we got 8 peaches, but in those other 2 times, we don't know how many peaches we got, so we could have got less, couldn't we? And the same here. Out of those 10 boxes, 7 of those boxes had exactly 8 peaches in them, but the other 3 boxes, we don't know how many peaches they had in them. We just know it wasn't 8. Okay, so explain why this label may not be suitable for use on the boxes of the peaches. Because the boxes that did not contain 8 peaches could have contained less than 8 peaches. We do not have that information. We do not have that information. Okay, there we go then. Right, it has been decided to record and plot the relative frequencies for the information shown in the previous table. Complete the table below. Relative frequency must be recorded to 2 decimal places. Now, relative frequency is like probability. So if we look at this, it's saying at 1 a.m, 8 out of 10 boxes contained 8 peaches. So 8 out of 10, as a fraction, be 8 over 10. Turn it into a decimal, you get 0.80. Okay, at 2 a.m, by now, you've taken another 10 boxes, so now you've looked at 20 boxes altogether. And out of those 20 boxes, 18 of them had exactly 8 peaches. So 18 out of 20. So 18 out of 20. As a decimal, if you don't know, do 18 divided by 20, and you should get 0.9. But we need 2 decimal places to 0.90. Okay. By 3 p.m, they'd looked at 30 boxes, and altogether there were 25. I'm getting these numbers by adding these up, look. So 25 out of 30, so 25 divided by 30 is going to give us 0.83. By 4 a.m, there were 32 boxes of exactly 8 peaches out of 40 boxes altogether. So 32 divided by 40, that's going to be 0.8, so 0.80. And finally here, we've got 50 boxes altogether now, so 41 out of 50, which is going to be 0.82. Okay, so there's my values, and now I need to plot this on my graph. So what have I got? I've got to point 9. Okay, so I'm going to go 0, 0.2, 0.4, 0.6, 0.8 and 1. Okay, so that means that every little division is 0.02. Okay, because there's 0.1 there, 0.3, 0.5, 0.7, 0.8. No, sorry, 0.9. Right, Okay, so at 1 a.m. the relative frequency was 0.8. At 2 a.m. the relative frequency was 0.9. At 3 a.m. the relative frequency was 0.83. So it's 0.8, 0.82, 0.83 by there. At 4 p.m. it was 0.8. And at 5 p.m. it was 0.82. So there we go. Joining those points up. Okay. The box of peaches is selected at random. What is the best estimate for the probability that the box contains exactly 8 peaches? Now, when we're looking at experimental probability, the more often we do an experiment, the closer it is to the actual probability. So we'll always use the probability which has had the most number of trials. So in this case, when we've got 50 boxes, that's going to be the most reliable. So the answer is 0.82.